Hi, my name is Tu. I am in the Sandia National Labs clinic team, and I am here to talk about my milestone 3, which is to get the smoothie board working and control all 3 axes. And I'm actually here to talk about the problems I had and why they aren't moving. So the first problem I'd like to address is that the logic level on the smoothie board is actually 3.3 volts, and the logic level for the driver that I'm actually trying to power on is 5 volts. So the solution to this I found was to use a level shifter, if you can see that, which is to take the 3.3 volts from the smoothie board and bump it up to 5 volts to power the external driver. And so I hooked everything up. I have the signal lines coming in from the board from M1 here, which is just the x-axis, to the level shifter, to the external driver. And result, nothing was moving. So did a couple tests. First, I would like to talk about the first test I did. I hooked up the board to the oscilloscope to test signals and voltage on the low and high side of the level shifter. I checked the direction signal line, because that's the line I actually want to look at. And if you look at a little sketch here, just a quick overview of direction and the pulse line. So the direction line is what I want to test. And so when I send the direction line high and pulse it, the motor should turn one way. If it's a low and I send a pulse through it, the motor should turn the other way. So instead of testing the pulse line, which would just read just a signal going up and down, I'm going to test the direction line to see if it's actually getting the correct voltage or current going through it. So I check the direction signal line. When you send in commands to move a certain direction, it changes the logic level direction line, like I said. So the first test was to take it through the oscilloscope. One side of the scope was on the low side and the other scope was on the high side. I sent in G-code to move the x-axis forward and backwards through prompter phase. I'll bring that up right here. Right here. So this is prompter phase, and I sent in G-code through here. And I'm going to bring up a couple of the graphs I see. So the graphs on these read the direction line, and you can see it's about 164 millivolts. That's really low when it's off, and when direction line is on the low side, and when it's high, it'll read 3.2 volts. Sorry, that's on the low side. Okay. So the voltage, you can see it jumps between 3.3 volts or 5 volts to almost 0 volts. And they really didn't tell me much other than that the direction line was turning off and on, which is what it's supposed to do. The second test I wanted to do was take the digital multimeter and measure current going through the direction signal line. So I hooked up the DMM on the direction line and ran a similar simulation with G-code to measure current. So you see here, you probably can't see through it actually. I took the direction line, which is this one, go in, and I hooked the DMM in series to the external driver. What it showed was that the high side of the current measures to be about 3 milliamps. So I wanted to know why there was a decrease in current, because each pin on the board actually outputs 4 milliamps. So I measure the voltage on the direction line when the current equals 3 milliamps, and on the direction line it reads 2.6 volts, which is not correct, because the voltage or the level shifter should have shifted it to 5 volts. So I wanted to know why there was a decrease in voltage. Originally, I had the high side voltage, the 5 volts, coming from the board, and I thought that the board couldn't supply enough current. It was drawing too much current from the board, And so I took the high side to the power supply and to see if the voltage drop was still there. And as you can see, this is still on, and the voltage drop is still there. So I don't know if I mentioned this a little bit while explaining this, but the external drivers are 5-volt logic, and they need a 10 milliamps minimum logic supply current. And I just showed you that the measurement, I'm only supplying about 3 milliamps. So this is a problem for the smoothie board, and I'm still looking at possible solutions to drive the current higher to power these external drivers. Possible solutions is to bump up the current through an NPN transistor of some sort on the direction and pulse signal lines to the external driver. Other than that, I'm going through more solutions to see how I can supply enough current through the driver. But yeah, those are the problems I ran into with my Milestone 3. It cannot be completed at this time until I can get the current buffers or the transistors to work at this time. All right, thank you.